Well, hello again, everyone, and I'm here. We're going to go over again the third video for chapter one. This is kind of about the organization of the body. This is going to and the organs and how they are organized, and a little bit about how our body has these amazing mechanisms to make sure that when those organs do their job, they don't disrupt the things around them. So we are going to look at this. This is going to tie into our lab stuff. So when we look at how the body's organized, there are two main portions. We call one the axial portion, which is the head, neck, and the body, which we refer to as the trunk. And then the appendicular portion, which are the upper and lower limbs. It would commonly be referred to as arms and legs. Now we'll see at a different video that the word leg, for instance, isn't the entire lower appendage if we're talking in science. So we have to learn to kind of know how to speak science. Even though we live in the real world, we need to understand that there's certain things that that are more specific when we are talking science-ese. So axial and appendicular portions, axial head, neck, trunk. Appendicular, the upper and lower limbs. The major body cavities we're going to see come from mainly the cranial and cranial cavity, which is where the brain is, vertebral cavity or spine, or vertebral canal or spinal cavity, has the spinal cord. We don't look at those a lot, and as a matter of fact, I'm going to take my little video off here so we can see the entire slide. As a matter of fact, these two make up what we call the posterior or dorsal cavity. The thoracic cavity and the abdominal pelvic cavity, these two work together to make what is called the anterior or ventral cavity. And those are the ones we're really mainly going to look at. Now, in these body cavities, there is a distinct dividing line between, when we're looking at the anterior ventral cavity, there's a distinct dividing line that separates the thoracic from the abdominal pelvic cavity, and that is a muscle called the diaphragm. The diaphragm is the main muscle of respiration. Now, in the thoracic cavity, there is this little spot called the mediastinum right in the middle of it. There's a lot of things in there. The main thing we look at is the heart, but it's got the esophagus, the trachea, several things in this little area. It literally means middle sternum. Mediastinum, it's kind of like middle behind the sternum. The abdominal pelvic cavity also has two portions, the abdominal and pelvic cavity, which is nice. Sometimes science get things pretty well named, not always, but most of the time if we understand. But the abdominal pelvic cavity contains the abdominal and pelvic cavity. So that's kind of nice. So let's look at them. If we were to look at, I was hoping I could magnify this, but I don't see how, but that's all right. If we were to look at things from this view, you can see, and again, I'm using the mouse pad, so hopefully, you bear with me that it is kind of sketchy on here. But I have a posterior dorsal, which means back, all right, things to the back, cavity that consists of the cranial and vertebral canal, cranial cavity, vertebral canal, or like we say, spinal cavity. And then we have this entire area here called the anterior or ventral cavity that is broken up into the thoracic and abdominal pelvic cavity. Now, this is the way, this diagram over here is how we look at it in lab. And again, the diaphragm is right through here that divides the thoracic and the abdominal pelvic cavity. We really, on this view, don't look at the cranial cavity or whatever. And so this is what we look at in lab, like I said. And so we have three main areas because there's no clear dividing line. We'll look at this in the skeletal system, the dividing line between the abdominal cavity and pelvic cavity. And in this, what I want to just concentrate on is use this cavity as one cavity. We look at these, the organs of this cavity will be as a group. And so we're really going to start looking at how our organs are organized in these three cavities. So I have one on either side here for the lungs, the heart here in number 2, and then all of these together in 3. And we're going to see how these organs have a two-membrane system. And before I go to the next slide where we start looking at these, I want to remind you, we talked about in the first video how organs are just anywhere that have more than one tissues working together. And so things like a bone, any individual bone, the little bone at the tip of your finger, that is the distal phalange, by the way, that is an organ just on its own, right? So, however, there is a distinct classification of organs like the heart, and the Greeks used the term viscera for those. And so we're going to look at these viscera and how this two-membrane system, which we call serous membranes, works. And as I say that, I missed the next slide because this talks about some of the small cavities. I kind of take this for granted. Hopefully everybody that's watching this knows oral cavity is mouth, nasal cavity is nose, orbital cavity is going to be the eyes, middle ear cavities are inside the ear. There's going to be a picture, yay, of this. I'm hoping that we don't need to go over those. This is where I wanted to talk about with these membranes. All right, so this is called, these membranes that we're looking at that are surrounding our viscera are called serous membranes, and there's 2 layers for each of them. And the first layer is called visceral, right? This is the layer that covers the organ. This is the layer that is basically the skin of the organ. It is called visceral because it is on the viscera. The parietal layer, on the other hand, forms the cavity. All right, and in anatomy and physiology definition, the word parietal means cavity. We're going to see that the 2 largest bones of the cranial cavity that we look at are called parietal bones, because together they make up the majority of the cranial cavity. Now, you can remember it also if you've got kids, you've got a parietal duty to form a protective barrier around your younger kids to make sure that they don't run with scissors, so to speak. So hopefully those 2 terms make sense, because if you understand visceral means organ, you understand that that's the membrane that's on the organ. If you understand parietal means cavity, you understand it is it's the membrane that forms a cavity. And the way it works is if I have, and we'll say, because everybody knows our heart is like this, and I'll change colors here. And so the red represents the visceral membrane on the heart, and because it's on the skin, and then this dark line represents, trying to concentrate here, he represents the parietal membrane. There is what we refer to as a potential space between them. That potential space is filled with serous fluid, which is very slippery. So if you can imagine having a Ziploc bag, the little plastic saran wrap around the heart, and then covering it with a thin film of olive oil, and then putting another saran wrap bag around it. And as the heart beats, see, the heart twists as it beats because it beats very violently. I don't know if anybody's ever seen that happen. You know, if in today's world you can flip through and see an open heart surgery. So if you've ever seen the heart beating, you will know that it beats very violently. Again, it's pushing blood out to roughly, on average, 60,000 miles of blood vessels. So what happens is those 2 membranes, right, the visceral and parietal membranes, there's a little bit of slippery fluid between them, so the visceral membrane slides inside the parietal membrane. Now, when we are looking at, if we were to go back to that picture and look at the body cavities, and we said there's 3 areas. The areas where the lungs are, the area where the heart is, and the area of the abdominal pelvic organs. Those have this serous membrane system on them. And so these are named in a 2-word name. The first word is going to tell you if it is either on the organ It'll say it's visceral, or it is making the cavity. It'll say it is parietal. So if I'm talking about the heart, if it's on the heart, it is visceral. Now, to know, that's just telling me if it's on the organ or makes the cavity. The next word of the two-word name is going to tell me which organ it's talking about. So the heart is called pericardium. So if I am talking about this membrane that forms the cavity around the heart, it is the parietal pericardium, because that's the first word's telling me it's making the cavity, the second word's telling me that it is of the heart. So then we look at, let's say, the lungs. So if I'm looking at the lungs are called pleura. This word actually comes from meaning more than one. That's where we get our word plural. You've got two lungs. So if I'm talking about the membrane that is on the actual lung, it is called the visceral pleura. If I'm talking about the membrane that forms the outer cavity, it is the parietal pleura. It is simply a mix and match. The organs in my abdominal pelvic cavity are surrounded by membranes that are referred to as peritoneum. Now, if I am talking about my small intestines, I have a membrane that is on the small intestines. It is called the visceral, because it's on the organ, peritoneum, because that organ is in the abdominal pelvic cavity. If I'm talking about the one that is lining or making a cavity, it is the parietal peritoneum. So there are 6 different membranes in these 3 systems. The first word describes whether it is on the organ or forms the cavity. The second word tells us which organ we're talking about. All right, so hopefully that makes sense. If I'm looking at this picture, and I'll draw kind of red right in here, I'll draw a little arrow to it. This, and I'm not going to say it right away, we were watching this video, I want you to think about it. This membrane is on the organ, and the organ we're referring to is the lungs. So this is going to be the visceral pleura. Across from it, and I'll draw it over here so it'll show up, across from it, I have a membrane that's outside, that's making the cavity. When talking about cavity, we're talking about parietal, and since we're using the lungs where we're pointing to here, it is the parietal pleura. If I was talking about the heart, I will draw, let's see, I'll use yellow, maybe that shows up. All right, so if I'm talking about the heart, this membrane right here at the, that's on the surface of the heart, that is the visceral pericardium. If I'm talking about the membrane, and I think that the red would probably show up here better. If I talk about the membrane right here, this is the parietal pericardium because it's forming the cavity. The next picture is the abdominal pelvic cavity. And again, I don't want to get, I feel like we're going over and over again. I probably would not use this picture because of all of the kind of craziness going on here, but just in case, this is the small intestines right here, the stomach and the small intestines. If I'm looking at this inner one right here, that is the visceral peritoneum. The outer one here is the parietal peritoneum. Again, I probably wouldn't use this. I would keep with the previous one, but just showing you again. Visceral means organ, parietal means cavity. If we're talking about a membrane on the organ, that is the skin of the organ, it's visceral. If we're talking about the membrane that forms the cavity, we're talking about parietal. There's only 3 organ systems that we're generally looking at: the lungs, which are called pleura, the heart, pericardium, the abdominal pelvic cavity, which is peritoneum. And so it's simply a mix and match. The first 2 letters tell me if it's on the organ or forms the cavity. The second word tells me which organ we're talking about. So I hope that makes sense. It's really straightforward, but again, it's easy probably to just try to memorize these, but if you understand the words, these words will come back over and over again, and it will be helpful just to understand the words. And if you understand the words, you will not be tripped up. So again, I hope that makes sense, and I hope you all have a wonderful day.